A smile is a welcome sight that invites people in. It's a welcome gift to encourage others to achieve greatness. A very good evening to one and all present here. I'm Josna Vinci from the Department of Electronics and Communication Engineering. On behalf of St. Joseph's Institute of Technology, I'm here to host today's session. It's my great pleasure to extend a cheerful welcome to you all for the Student Development Program on the topic TinkerCAD Design. Now, I would like to extend my first and foremost gratitude to our Honorable Chairman, Dr. B. Bhavamanohar sir, Managing Director, Mrs. S. Jessipriya ma'am, Executive Director, Mr. B. Sashishekhar sir, and Principal, Dr. P. Ravichandran sir, for giving this opportunity to conduct today's webinar. I would also like to extend my gratitude to our Head of Department, Dr. C. Gnana Kausalya ma'am, Staff and Student Affairs, and Dr. G. Rohini ma'am, Lab Affairs, for the ceaseless support. Today, we have the privilege of welcoming our distinguished speakers, Mr. Vigneshwaranti and Mr. Sham H., who embodies the true spirit of innovation and dedication in the field of artificial intelligence. As an AI enthusiast, this individual has not only shown a remarkable passion for the subject, but has also translated that enthusiasm into tangible accomplishments. Being an active member of IEEE prestigious community, her speaker has actively contributed to the advancement of AI research and development. In the realm of messaging platforms, our speakers have made significant strides in the automation of WhatsApp Messenger using AI. This integration of AI with one of the most popular messaging apps highlights the ability to harness technology to streamline and enhance user experiences. Their expertise in utilizing tools like Sklearn, Matplotlib, Pandas, and NumPy has enabled them to extract meaningful insights from complex datasets and make informed decisions. It's also worth noting their dedication to voice synthesis as showcased by the useful usage of PyTSXT. This skill represents another dimension of the AI expertise, enabling human-like interactions through voice. Now, have also won in many intercollege symposium and hackathons. I would like to invite the speakers to start the session. But before we start the session, keep in mind the following instructions that need to be followed by the participants. Kindly turn on your camera and mute yourself. Post your queries in the chat box and they will be discussed with the speaker at the end of the session. The feedback link will be posted at the end of today's session. Now I invite our speakers to kindly start the session.
Hello. Can anyone acknowledge me? Am I audible?
Yeah, Vignesh, you are audible.
Thank you, bro. Good evening, everybody. I'm Vigneshwaran from third year ECE department from St. Joseph Institute of Technology. And I'll be taking the session on design and control through TinkerCAD. And before starting the session, I would like to know whether the participants have participated and done any projects in any science projects or any kind of projects in school. Participants kindly interact. So this session is going to be fully hands-on and more than theories. We're gonna learn something by doing by ourselves. So kindly come on, guys. Let's be interactive and learn something today. Is there anyone who have done any science projects or experiments in school? Even you can share the experiments which you have done in your physics or chemistry laboratory, which you have which you been doing in the practical sessions. Okay, fine. So I'm going to tell what is what TinkerCAD is about and what we can do with TinkerCAD. How how we can design something using TinkerCAD. So I'll start with my presentation. I'll share the screen now. Shamana, is the screen visible?
Yeah, Vignesh.
Okay, Thank you. Okay, I'm starting with my presentation now. And okay, the first thing, what is Tinkercad? Can anyone from the participants, did you guys came across this word Tinkercad or any kind of tools like this? Have you guys have worked any in something like this? If you have worked, you can come up with that. You can just share what you know about that. Okay, fine. Okay. Tinkercad is something which we use to design uh, mostly 3D objects, circuit simulation, and block coding software package. And these are the blocks, the things we can do through Tinkercad. So, as an electronics student, we majorly focus on circuit simulating. So, I'm going to teach you that only today. And then, so you have now an idea of what is Tinkercad is about. It is about designing something. Okay, it is a simulation software. Okay, it is creating something which we can feel in the real world environment. And next one, what is Tinkercad circuit? It is a part of Tinkercad. Okay, which I have told like we majorly focus on building circuits. Tinkercad circuit section is a browser-based electronic circuit. It's not any a software anymore. You can't download that software. It's built in the web browser. You can work in the web browser by connecting through internet. So it is a browser-based electronic circuit simulator that supports Arduino Uno microcontrollers. I will tell you about what is Arduino Uno and what is microcontrollers and everything I have in the future slides. And next one. What is simulation first? We have told that Tinkercad is a simulator. It's building circuits, building 3D models. It is simulating, right? So what is simulation first? Simulation is something that is being used to imitate something. So we have robots now, right? So robots are what it is a object or it is a combination of every mechanical, electrical, and electronic components together, functioning together to imitate something. So for example, take a chitty robot. It imitates human actions. Okay, so this is simulating. So this is what simulation is. Imitating action of an object or something is called as simulation. Okay, simulation require the use of models. They actually need something to simulate. Okay, uh, they are the key to simulate something. So we have heard of mimicry, like simulating someone's voice. So this is what simulation is. Simulation is applicable in every field. So recreating or imitating the same process is called a simulation. Okay, and then we move to what we are simulating using Tinkercad. As I told, we simulate only circuits, and we can also simulate 3D objects and other software packages also. And in this session, we are going to simulate embedded projects based on Arduino Uno. You guys may not be knowing these things. Someone may be having idea. No problem. I'll explain in the next slides. And then interfacing sensors and actuators with Arduino. So Arduino is basically a board. It is an electronic board, and sensors and actuators. These are all everything is an electronic component. I'll explain you. So before getting into embedded, the embedded is a domain, is a drastic domain like web development, artificial intelligence. Likewise, it is a domain, a technological domain. Okay, where people even work in a lot of industries like HCL, TCS, Wipro, and every company worked on their embedded projects. So we are going to see what is embedded, what embedded is about. So before getting into embedded, we need to know the basics of microprocessor and microcontroller. So what is microprocessor and what is microcontroller? We are going to see in the next slides. So before that, don't get confused. Every technical words here are like a complex term to understand, but it is very easy. You will be feeling slight in the coming finishing all the slides. Okay, we need to know the basics of microprocessor and microcontroller. In an acronym, we call it as a MP and MC. And then, what is a microprocessor and what is a microcontroller is about. Okay, microprocessor consists only of a central processing unit. So you guys have been reading about a basic computer hardware, like a basic computer in architecture like that. So you guys would have heard that word central processing unit, which is a CPU, which is a main component for a computer, right? So for a general purpose computer, central processing unit is a very necessary and a very meaningful component. And microcontroller contains CPU, memory, IO, all integrated into one chip. So I'll explain you what this is about. So let us take a general purpose computer, the computer which we use in our labs and homes and everything. Okay,
Vignesh?
Shamana? Yes, ma'am.
Yeah, someone from the participant has raised their hands. I think he
Ah,
has some question to ask.
okay, you can.
I think it's from Stephen Vishnu.
Come on, bro.
Stephen,
Stephen.
if you have any question to ask, can you just unmute yourself? Vignesh, you carry on.
Okay, now. Okay, guys. Like we have been talking about what is a microprocessor and what is a microcontroller, right? So I'll explain you. So the microprocessor consists of only a central processing unit, which I have told. So let us take the general purpose computer, the computer which we always use, even the laptops also. So while buying computer, we would be going for specifications. Okay, so if you are purposefully building a PC rather than buying a built one, uh, by building a PC, you would have planned something, the processor, the RAM, and everything. Okay, if you don't know also, if you go to a shop, I want to build a PC, they would ask what is your applications, where do you use your computer. If you go for any high uh, graphics or a high-end gaming like that, they will be suggesting a high-end processor with added GPU like a graphics card and that. Uh, if you are going for low end, you will be requiring only a small processing unit and very less complexity compared to your high-end performance, right? So uh, your processor is a major thing, playing a major role in the PC building process. Okay, without processor, your computer can't able to take decisions. Only the CPU unit, which is called as the processor in the computer, is capable of executing the desired task you plan to execute. Okay, so this is basically a microprocessor. The all the chips chips means chips in the sense this is a processor. The Intel AMD processors which you use in the general purpose computers are basically a microprocessor. And then a microcontroller. A microcontroller contains CPU inside it as a subset. Okay, and along with it, the peripherals like memory, input output pins, and something like additional memories analog to digital converters. These parameters are included inside the microcontroller. So a microcontroller consists a microprocessor inside, and along with it, it consists all the peripherals and additional components needed to configure a system directly. With a microcontroller, you can directly configure any system, but the major problem will be in the microcontroller. Why? Because the Intel or AMD chip which you buy in the computer shop, which is you are going to build in your PC, will be a high performing one. Why? Because in your PC you are downloading already the Microsoft tools would be of larger space. So the performance, sorry, the tasks you run on this PC will be of greater complexity. So to run these tasks, you need a maximum processing power. So the microprocessor offers that power, whereas a microcontroller, they cannot offer that kind of executing power. Okay, why? Because a microcontroller is dedicated for a particular task. In every aspect, it is dedicated for a particular aspect. Okay, I'll demonstrate this in the future slides. Okay. Okay. As I said, microprocessor are used in personal computers and microcontroller is used in embedded systems. And this is what I said as a specific task. I'll tell about embedded systems now. And then, what is embedded system? Okay. An embedded system is a combination of computer hardware and software designed for a specific function. Okay. An embedded system actually works in this way: software plus hardware equal to embedded system. So as I said, microcontroller is a kind of board which is included with all the processing unit, memory unit, everything. Okay. Uh, uh, in upcoming slide, I'm having a slide dedicated for Arduino. Arduino is nothing but a development platform which is meant for learning embedded system. Okay. For initially learning embedded system, Arduino is a very basic tool you have to learn. Then Arduino not only offers hardware, they also provide an software, which is called as an IDE. Okay, so software plus hardware equal to embedded systems. So embedded domain is called as a firmware. In every industrial embedded aspect, if you ask a person in embedded whether they are working in a software or a hardware field, they will say like, I'm working in a firmware field. So you might be wondering, what is a firmware? So this is exactly what is firmware: software plus hardware. What you actually do in embedded systems is, so you take a hardware which is having its own architecture of microcontroller, and they will be having its own memory, own processing unit, and all GPIO pins, which is called as general purpose input and output pins. These are all parameters or constraints inside the hardware. So what you do is, you take a piece of software, you want something to perform in the instruction or the architecture of the hardware. So you dump the software code in the hardware, and the hardware resembles something for a specified function. For example, we take what washing machine in our homes. So what washing machine does is, it takes cloth, it takes in a container, and what the processing unit does is, it dedicates a time for 1 hour, right? It may take up to 1 hour to 1.5 hours, and it takes all the clothes. It first dries, and then it first soaks, and then rinse, and then it will dry, right? So this is a process of washing which is coded by a software, and the code is dumped in a hardware which is specified for this washing thing. Okay, so to perform a thing, you need a code to run. Okay, so this is what embedded systems is for. So washing machine is a very good example for embedded systems, and other like appliances like refrigerators and like televisions. Everything is embedded inside. uh, if you get deeper into it, you may be wondering, you may be knowing what is embedded is actually. Okay, then what is Arduino? As I said, Arduino is basically a microcontroller board, and rather than saying Arduino as a microcontroller, you can say Arduino as a development board. So Arduino is a development environment. They have their own hardware, they have their own software as an IDE, integrated development environment. I'll be saying what is IDE, and then they have their own website. They can even guide you to do their projects. What are all the components needed? They provide only the microcontroller, the sensors and other things they have to buy. and we have to interface with the thing. Okay, and then this is actually Arduino board. You guys can see this board uh, is a development board, right? Though, so the chip which is in the center of this board is the microcontroller. Okay, this microcontroller board is manufactured by a company called AVR Atmega AVR boards, but the chip name is Atmega. Okay, and they have their digital pins here. They have their analog pins here, and the power supply units and the voltage regulator. So the maximum supported voltage for this board is some 5 to 20 volts, but above some 9 volts for a specific function, this board will not work. Will work, but this voltage regulators do this process of converting what the excess voltage is to the minimized voltage. Okay, so this is all about this board. And then, so okay, Arduino is an open source electronics platform based on easy to use hardware and software, as I said. Okay, so Arduino has its own IDE. IDE, what is meant by IDE? IDE is integrated development environment. What this IDE actually do is, IDE is where you can develop the code based on their individual architecture. So Arduino will be having its own architecture of programming. Okay, so to print something in any programming language like C or Python, we'll be using the print statement like printf or just print. So in print something in the Arduino's monitor, there is a monitor called in Arduino called serial monitor. Okay, so to print something in the serial monitor, we have to print as serial.print. That is the print function in Arduino. So this is a individuality of the IDE. Okay, and then, okay, we have the hardware, we can purchase it, and we can just go with the things. Okay, so we need to go for simulation in Tinkercad. Tinkercad is about simulating these circuits with Arduino and sensors and things. So why we need to go for Tinkercad simulation? These are all the points. So reducing hardware complexity. So to just execute a process, you you guys need to work on the hardware, right? So it may take you need to buy the hardware, so you need to test everything on that. So if you made any error means the hardware will be damaged. So many constraints are there. So reducing this hardware complexity is a major role of Tinkercad. And there are many simulation softwares other than Tinkercad. To majorly work on Arduino, we work with Tinkercad. So then time saving. So as I said, if you want to buy hardware and connect with these things and you want to test a project means, so obviously it will be taking more time. It will be taking more time. So it won't be convenient, right? So to take things right, first thing is to simulate the process. If the simulation is working fine, then you can go with the prototype. And then better project understandability. So if you are connecting a project in real time, it will be so messy. In initial phase, the project will be so messy. Why? Because you will be connecting a lot of components. There will be a lot of wiring. If you do it in an organized manner, there is no issue. Still, many of them suffer with this problem. Better project understandability or managing the project is a major constraint in developing a project. So these simulations will help in better understandability. Okay, okay, and then error debugging. So in the hardware, you will be exposed by getting a lot of errors. Okay, uh, so these errors can be debugged only by your hands. You have to change the connections. You have to check once again and once again the circuit, and there will also be the problem in the code. Code issues are solvable by systems, but the circuit issues are the major issues. So you have to pick by your hands and you have to solve that. But in a simulation, you can easily debug the circuit problems using the software. Okay, these are all the constraints, and this is what, because of this only Tinkercad is very important. And then, and I have said about sensors and actuators. Okay, what is mean by this? Okay, sensors are devices that is used for physical events, conversion of physical events or characteristics into electrical signals. What is this sentence means is, to if you want to sense something in an environment. For example, uh, in my room, the temperature is around 25 degrees Celsius. We know this by seeing the weather app in our phones. So our phone is having a slide of a temperature sensor. Okay, this is a real time sensor, but we have some sensors which are readily available in market, and we can use these sensors to sense this data. For example, there's a sensor called as DHT11, which is a this is the name of the sensor, which senses the temperature and humidity from the environment, and you can get those values as a physical output. So what is this electrical signals means is, so we know that every data in the environment is an analog data. So to sense this data, we will be getting the voltage, the values in the form of voltage, which are called as electrical signals. Okay, and then it takes input from the environment and gives to the system. As I said, the data is fetched from the environment, and the system can process it further. Then this is what we can simply imagine is, sensor is an input side, and then actuator. Actuator is a device that converts electrical signal into physical events. Um, for example, we take a motor. What does a motor does? It requires a voltage input, and it rotates, and it is converted into a mechanical output or a physical output, and that output is important for an response from the system. Okay, if a system has to respond, if I press the button in forward in RC remote control, means it has to go forward. So for that I am giving only the instruction, the motor has to move. So their motor is an actuator. Okay, it takes the input from the system and gives the output to the environment. As I said that, examples, here they mentioned thermometer. Thermometer also can sense the temperature from someone's body and even in the environment. And actuators having an example of motors, as I said. Okay, we are done with the basics, and we can start simulating things in the browser, which is Tinkercad. So guys, if anyone using connected using laptop, means you can just go to any browser and just search uh, Tinkercad, and you have to first register, and you can just log in if you have registered, or you have to register first, then you have to log in. So I'm logging in with educators. So guys, after opening this, you have to go to the Tinker button, and then you will be seeing 3D design, circuits, code blocks. Go to circuits and start tinkering. Sorry guys, circuits, and mm, okay guys, Shamana will explain now about simulating using Tinkercad, and I'm handovering this session to Shamana.
Okay, participants, is my voice is audible?
Yes, Anna, audible.
Ah, okay, thank you. Okay, from here I will take over the session. Uh, Thank you, Vignesh, for your wonderful theory session. From here, I will going to show about the practical session. Vignesh, kindly stop your screen.
Okay, Anna.
Guys, kindly acknowledge whether my screen is visible. Guys, anyone from the participants, kindly acknowledge whether my screen is visible and you can
Yes,
able
Anna, your
to.
screen is visible.
Okay, thank you. So this is the workplace platform, which will be blank enough. Today I'm going to show about four different projects on connecting basic electronics parts with Arduino as well as with normal simulation. Before getting to simulation, I will show you the basic components. As everyone knows, this is a resistor and this is a LED. With resistor and LED, we can make our different projects, which will be very basic and it will be very interesting. By using an Arduino, this is the part which is called as microcontroller board, and this is also called as Arduino. As Vignesh said, this is a developing platform where we can dump your code and work several projects on it. These are the digital pins, and you will be proceeding from 5 volts to 20 volts. And inbuilt enough, there will be a reset button, and this will be the analog pin where you will be seeing the transmission and receiving part in here LED, and this will be the LED part where you will be seeing whether the Arduino is working or working state or else it in a dead state. Okay, this will be the start button, and here you will be plugging any other external circuit. This is the power supply circuit, and then I will show how to connect with a basic component like LED. Okay, I will be giving this to. Wait a second. Actually, this is the anode where you will be giving the power supply. You can change the color. I will change it to red and make it in a correct position. This is the cathode where it will be connecting it to the ground state. I will make it to black. Now see whether the LED is turning on. Actually, it is showing that LED can acquire just the basic voltage. As it is a simulation part, the LED won't burst or something. It will be showing the notification part as a it's showing correctly. Wait, as it's showing only for 46.6 mA will be current pass through the LED. So in order to stop this, I will add up some resistor. Okay, what does resistor do? Resistor will pass the current with some resistance so that LED or any other electronic device can perform in perfect condition. Make it to red color. Now see the LED is showing that it can be work in with resistance it, and there is no indication that the LED will be burst out or else LED has some defect due to the power supply. This is one of the project with LED. And then with higher end of LED, we are going to code with three different LEDs. Okay, I'm going to delete this. Delete this. I'm going to keep three different LEDs. As it can be controlled by using Control plus C, Control V, setting Control V. I will check whether all three in same position. As it is the digital part, I will connect all these three to anode, which will be the power intake, which is also called as positive position. As this is in red, I will make it as green. I will also change this color to yellow, and all this has a same ground. I will make it in a ground in the same pin. Let's see what will happen. Only one light is has got the power supply. Other two doesn't got the power supply due to the direct voltage to the single pin number two. So I will make it with a resistance. And the interesting part in the Arduino, we can code in the Tinkercad itself. Or else, if you have a hardware part, we need to download ideally software, and we need to integrate the Arduino with the ideally software, and you need to dump the code into the software. So still, the power supply is going into only in the first LED. So what we need to do is we need to make the code to run in proper way. So actually, this is the basic code where the Tinkercad itself generated. We need to edit with our code. So actually, I have a predefined code. which I had already typed in, typed and saved in several or another platform. A second. So let's see. Okay. Here I will change it to red. Here I will change it to yellow. Here I will change it to green. As it this platform is in dumped with C++ code. See, I'm going to introduce the LED red, which is will be in zero state, and it's numbered as zero, and it is yellow will be in one, and green will be the second. So I'm going to introduce a void setup. So all three LEDs will be the output, as the power supply is directly given from the 5.5. Uh, and then next I'm going to make a void loop where the green LED and other LEDs will be off. Sorry, green LED will be on and other LEDs will be off, so that this first LED will be on, other two LEDs will be in off state, and then after 2 seconds, which will be in milliseconds, 2000 milliseconds, we need to give the command only in milliseconds, so that the computer will be known. Then same code will be for a yellow, which will be in 1000 milliseconds, which will be considered as 1 second. And after 3000 milliseconds only, the second command, third command will be taken. So I'm going to give a simulation. So see, for 2 seconds, the green will be on. After 1 second, the yellow will be on. The same simulation process will be done. So if any of the participants are needed to need have a try with this simulation part, I will drop the link in chat box. Kindly move on to the link, and just you can work it in the same platform. So another one is we are going to work with the same and basic thing, which will be a normal motor. Wait a second. This is the DC motor. We all have worked in a DC motor, which will be in a remote control car, and be taking the 1.5 volt battery. So I'm going to give a connection with positive to positive, same like negative to negative. Same way I'm going to change the color. So the device will on and the motor will be done. So what is the difference? As a innovation, we are going to fix a photoresistor. What is a photoresistor? Actually, the photoresistor is a device which will be have a sense of light, and then at the output will be the electricity. Like say it will convert the light into any other form of electrical source. So I will make this connected to here. So the major purpose of this device is when the light source is on, which means photoresistor is on, the motor should be run. So let's see, why does the motor does not run? So as the intensity is zero, so if there is a light, the motor will be run. According to the intensity of the light, motor will run. This is the one of the basic hands-on practice on Tinkercad. And then I'll also drop out this link if you need it. And then, okay, guys, this is one of the hands-on practice. And then we are going to make a project. You can take this mini project or any other project for your school activities. So I'm going to do a project where with a photoresistor and normal bulb. The when does the sunlight goes down during the evening, right? So during evening time, my bulb should be on automatically. We are going to make a device that will make a bulb or any other electrical device that should be on during the night time, which is exactly after 6. Okay, this is the positive terminal and this is the negative terminal. So I'll go and plug into the ground. Same way, the photoresistor has the positive and the negative terminal. Actually, this is the analog device. We are going to give it in here, which will be on A3, and then we are going to give the second terminal in 5 volt. So the power supply should be given to the photoresistor. And then same way we are going to make a ground in a same way. So what will happen when the intensity rises? Bulb should glow. Why the bulb is not glowing? Because we are giving the Arduino device. You need to code in the device. So I'm going to dump the code in Arduino platform. I already had have a code. Okay, this is the code. In this LDR, that means light detector, which is also called as photoresistor, which is given at the A3 platform or A3 input. Actually, that is A3 means analog input. Okay, I will make it in different color so that you can have a better glance. So LDR will be in A3 uh, and bulb which will be connected in 7. And then I am opening the function which will call as void setup, saying that bulb is the output and LDR is the input, which means the intensity is as increases, the bulb should off. If the intensity decreases, the bulb should be on. So the intensity of the light, that means sunlight, when the sunlight is passed in a LDR, it has some intensity. If the intensity is less than 500, the bulb should glow. That is the if condition is being passed over here, the 0, and if else part, the bulb should be 1, which means on condition. Say, I'm going to give a simulation part. See, the bulb is glowing. The intensity, now the intensity is 0, which means it is night time. If it is the daytime, it should be off. Why it is not offing? Because we are not giving the resistance. So that still now the bulb is glowing. So when I pass the resistant into it, I'm going to add a resistor into it. Same way for photoresistor also I'm going to add the resistance. I think there's a little bit error inside the code. Okay, I will check with my code. I made a wrong connection to it. Should be in a power supply platform, and this should be the input analog signal. Oh, see whether my code is running. Yeah, actually it is in during night time the intensity is 0, so bulb is glowing. During daytime the bulb is going down. So this is the basic hands-on project which will be act as automatic light detection. During nowadays it is been a working condition where in the street light they are using this technology. It will be the automatic street light system. So that will be the last part of your hands-on session. Just now,
Yeah, no.
continue.
Yes. Dear participants, now it's your time. Kindly raise your queries. Unmute yourself, or you can also post your queries in the chat box. Thank you, Vigneshwaran, and thank you, Kamleshana. Sorry. Thank you, Shamana, for your wonderful session. The feedback form is available in the chat box. All the participants are requested to fill out the feedback form. Now it's time to express our gratitude. On behalf of Electronics and Communication Engineering Department, St. Joseph's Institute of Technology, St. Joseph's Group of Institutions, I would like to thank Mr. Vigneshwaran T and Mr. Sham H for sharing their wonderful insights with us. My heartfelt thanks to our beloved chairman, Dr. B. Bahuman sir, for organizing a wonderful webinar to gain knowledge. My sincere thanks to our managing director, Mrs. S. Jessie Priya ma'am, executive director, Mr. B. Sashishekhar sir, and principal Dr. P. Ravichandran sir for giving this opportunity to conduct the webinar successfully. And I would also like to extend my gratitude To our head of department, Dr. Sinyana Kausalya ma'am, staff and student affairs, and to Dr. G. Rohini ma'am, lab affairs, for their ceaseless support and guidance. Last but not the least, my sincere thanks to all the participants for your active participation and support. Thank you all.